Hello and welcome. In this video, I want to help you understand the quadratic formula and I want to show you where it comes from, and I'll aim to do that by going over this example solving for x. So here we have a quadratic, a trinomial, and it's equal to 0. We have to solve for the x-intercepts. I'll proceed by completing the square, but before I can do that, I need to move the constant to the other side of the equation. So I'll first subtract 7 from both sides, and that's going to leave me with 2x squared plus 5x equal to negative 7 on the right hand side. I want to complete the square, but before I can do that, I have to get rid of this leading coefficient of 2. I can do that if I divide everything by 2. So my next step will be to divide each term on the left hand side and the right hand side by 2. That's going to cancel the 2's out, and now I have a leading coefficient of 1, which will allow me to complete the square. In order to complete the square, I need to grab the b term, divide it by 2, and then square it. Recall that the b term is the coefficient of x, so here that's going to be 5 over 2. Now, it's important to note that dividing by 2 is also the same thing as multiplying by a half, and in this case, I'm going to want to see it as multiplying by 1/2 since I have a fraction as my coefficient of x. So I can do that here on the side, and I have 5 over 2 multiplied by 1 over 2. I multiply the numerators together, so 5 times 1 is going to give me a 5. And I multiply the denominators together as well. 2 times 2 would give me a 4, but I'm actually going to leave them unsimplified. So here I have 2 times 2. And remember that for this example, I'm not too interested in getting the solutions, but instead I'm trying to cook a recipe that will help solve for any degree 2 polynomial, and you'll see the purpose of doing this in a few steps. So just to recall, 5 over 2 divided by 2 is the same thing as 5 over 2 times 2. Now we have to grab this and square it because I want to complete the square. And whatever I add to one side of the equation, I'll have to add it to the other. So I'm left with the following statement. I have x squared plus 5 over 2x. I'm going to add the 5 over 2 times 2, raise that to the second power. Now I have the perfect square trinomial. And to keep the equality, I'm going to add 5 over 2 times 2 to the right hand side as well. On the left hand side, I can simplify the perfect square trinomial into its binomial squared by grabbing x and grabbing the 5 over 2 times 2. So here I get x plus 5 over 2 times 2. And this is all going to be squared. I have the binomial squared. On the right hand side, I'm left with negative 7 over 2 plus, and because we have a fraction here, we have a ratio, the exponent is going to distribute to the numerator and to the denominator. So I'll be left with 5 squared all over 2 squared times 2 squared. And 2 squared is the same thing as 4. That would be 2 raised to the second power. And now the second 2 being raised to the second power, I'm going to keep it in, well, I'm going to leave it unsimplified. So I'll write it as 2 to the second power. What I want to do next is combine these two ratios. So to combine them, I will need a common denominator. Notice that I already have a 2, and 2 squared means that I have 2 copies of a 2. So to make them in common denominator, I need to multiply by another copy of 2 and a 4. So here's what I'll do. The 7 over 2, I'm going to multiply it by a 4 and a 2. Right, this is not changing the value of that ratio. And that's gonna, the purpose of this is to have, again, the common denominator here. So here I'll have plus 5 squared over 4 multiplied by 2 squared. To make things a bit more clear, I'm going to take an extra step and simplify this part. So here's what I have. I have a negative 4 times 2 times 7, and I'm going to simplify the denominator. So I have a 4 multiplied by 2 copies of 2, which I can rewrite as 2 squared. And now you can see that both my ratios on the right hand side of the equation have a common denominator of 4 multiplied by 2 squared. On the left hand side, I still have this binomial squared. And now I am going to combine these two fractions together. I need to make a little bit more room. So now, as I was saying, I need to combine these two fractions on the right. And I can do that since I have the common denominator. But here's how I'm going to do this. Since we have addition, I can commute these two values. So I'll write the 5 squared first. So I have 5 squared, and then I have minus 4 times 2 times 7. And that's all over the common denominator of 4 multiplied by 2 squared. Now the goal here is to isolate x. And in order to isolate x, I need to get rid of the square. I can do that if I take the square root of both sides. And here on the left, the square and the square root are going to cancel. So I have x plus 5 over 2 times 2. And on the right hand side, since I have a ratio, the square root is going to distribute to the numerator and the denominator. And as we take the square root, we get plus or minus the square root of 5 squared minus 4 times 2 times 7. And on the denominator, the square root of 4 is going to be 2. And the square root of 2 squared, the square and the square root are going to cancel out, so I'm left with a 2. And to isolate x, I now can subtract by 5 over 2 times 2 to both sides of the equation. And I am left with x equal to negative 5 plus or minus. And notice that here we have a common denominator, so I'm going to combine the numerators here. So we have plus or minus root 5 squared minus 4 times 2 times 7. And all of this is going to be over 2 multiplied by 2. Staring at this for a few seconds, it looks like we haven't done anything special. All we've managed to do is to overcomplicate the solution of your x values. But we've actually done something extraordinary. Check this out. Let's look at the original problem. The original problem was 2x squared plus 5x plus 7 equal to 0. Identifying the a value, the b value, and the c value, you can see that the solutions follow a specific pattern. And things get better because this is going to work for any quadratic equation in standard form. As long as you get the a value, the b value, and c value, you can plug it in onto this recipe and it will spit out the solutions or the x values. We can generalize this pattern and we have the super famous quadratic formula. More formally, the solution of a quadratic equation in standard form, as long as a is not equal to 0, is given by this formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.